Everyone, good morning. I'm Babita. I'm working as a postdoc at EGA. And as Aina mentioned before, I will throw some light on Beacon, or why this tool was created in the first place, and what are the challenges we are facing with regards to the sensitive data in biomedical community. So I'll start with the slide that, of course, sensitive data is sensitive. It's like our fingerprints. It has to be protected because it reveals our identity. And I would say that it reveals more than just our own identity. It reveals, your family history, your family tree, the diseases your ancestors have, or for your next generation. So even, we can go as far to say that how much genomic data, you control your own genomic data is also debatable in that sense. So therefore, it needs utmost privacy protected laws, and the data should be treated very sensitively. Saying that, what is happening now is because of this, it's the biomedical research community that is paying the price of this sort of sensitivity that holds around the genomics data set. And sorry, so this is not my slide. I am stealing that slide from the ECCB conference that I'm attending these days. So this was one of the workshops given on machine learning good practices, but it conveyed it holds the message that I wanted to convey. How biomedical research community is paying the price is because now, in the terms of now, with the age of AI and machine learning tools, what we want is our data to be as heterogeneous as possible, should be representative of all population around the world. It should be all, include all sort of gender, ethnicity, etc. But Macha presented that there are several papers coming out now that how biased these data set is, especially in the machine learning. If you say medical data, if you take medical data training, it's mostly based on white male. For example, 44% cases of liver disease among women are missed. So these are the challenges that the community is facing. So with this, I would like to now present some challenges, and then how we are tackling to overcome these challenges of data discovery through Beacon. So this is the paper published by Ivan Berney in 2017. And he predicted that most of the data in biomedical research was coming from research laboratories. So, in the research laboratory, data is generated in a very, focused, oriented manner. So you are studying this disease or this topic, and you are creating your control data set exactly versus that whatever topic you are studying. And then you are studying, control versus disease, or control versus wild type. So this was the scenario. In 2012, only 1% of the data was coming from hospitals, real patients' data, from clinical care. By 2017, it became 20%. So medical communities started participating more in the data generation, data creation, looking into the genomics of the real patient. And real patient, when I'm saying is like entirety of it's not controlled set of experimental group. It's more this patient, if suffering from heart disease, it could be also additional factors. A person could be diabetic as well. So this kind of, all case scenario. And then Ivan Berney, in this paper, he predicted that by 2022, 80% of the data is predicted to be coming from from hospitals and, real patients from the clinical setting. We are in 2022, and this prophecy has not been true yet. We do not see 80% of the data coming from medical community, but of course it has grown. It has grown. Many clinicians and medical practitioners are looking at the mutations or profile of the patients, or recommending genetic testing. So this is good, but we are not there what was predicted. Then he highlighted some challenges why when we arrive to the 80%, sort of data from the hospitals, what will be the challenges we will be facing, or what are the limitations there. So here I have highlighted a few challenges that was in the paper, which is, for example, geographical distribution of the data, as Aina presented before also. After GDPR, it has been said that the data is not supposed to leave the place where it was generated, the country it was generated. For example, Germany, data generated in Germany should stay in Germany. This is one of the GDPR's compliance you have to follow. So this was one of the challenges. Second was data access dynamics. So how these data access will happen, what sort of permission and governance on the data should be there. Clinical data, how to make it interoperable, because as you see, for example, in European countries, every country has its own language. So the data is also stored in their own language. So how to make it interoperable, as in you can access the same data, you can understand the same data from English-speaking country or from German-speaking country. How will medical community will get equipped by handling the volume of the data set? They are not prepared for hosting or such kind of huge amount of data set. Technical challenges, as we are talking about hospitals community, for example, we do not expect bioinformaticians or technical people to be working with the pipelines and tools to maximize the data that is being generated. Again, other concern is attitude and actions toward open data. As I said before, this data is very sensitive. So it's very, this needs to be discussed, that how to make people comfortable enough to share their data, provided you can, make them feel that the data is not going to be sold to the private company, et cetera, et cetera. So this kind of, the attitude and action needs to be changed here. And again, secure access and governance. So it's all sort of law and, what sort of laws apply, what is my right on my data set, et cetera, et cetera. So these are the concerns that he highlighted. And we are happy to say, as also Aina presented previously, that at EGA, we are tackling, all of these problems one by one that surrounds around data. So the geographical distribution, for example, as Aina said, we are working on local EGA. So you can basically replicate the entire EGA in your country or in your community, what sort of, in your hospital even, what sort of data. So your data stays with you. And what you're doing is basically you're bringing EGA there to your data set instead of giving your data set to EGA. So this is developed here in EGA as well. Then, as Aina, I will not mention anything because Aina has wonderfully explained everything about Duo and AI and data passports. To have sort of permission to access, what level of permission you're going to have to access those data set. GA4GH tools and standards like Crypt4GH, and to make data interoperable. Packets, for example, here is a big example that Aina presented. For storage, we are working with partnership with EBSC for the storage of the data set. Discovery tools and pipeline development. Again, we are tackling this. Beacon is one of the examples here. We are collaborating and for reach out activities with medical healthcare providers and schools, and giving talks around data and how we are dealing with sensitive data set, so you do not have to worry about the privacy concerns, etc. And tools and standards, we are working with governance policies, etc. So being said that, I want to also say that even though we are working and tackling these issues, the healthcare data discovery scenario is scary. Because it's been just like, it's a small step we are taking, and it's not that we are outreaching to all, everywhere yet. So it's very scary scenario. And why it is scary is, I will give you a few examples. For example, on one hand, we talk about sensitive data set, and on the other hand, people who are really have a need to find mutations similar like their own profile, or the kid has some rare mutation. What do? They directly go to Facebook and they post, they create this sort of group. If you search on Facebook a mutation, you'll find this kind of groups that are already there, where people are searching for, patients like themselves or patients like their kids. And this is not private at all. As you can see, there is, people are revealing their identity, but what is they are in need, what do you expect? There is nothing that, the alternative there that they can go. Another scenario about one of the challenges is, if you have gone to your medical, CAP, and if they have prescribed some sort of genetic screening, you will see the report arrives in this sort of PDF format, which is totally not structured. Reports have been downloaded from internet. So But it is the scenario everywhere you go. You know, it's like there is no common consensus how the data should be at least written. Even if you think that we can extract these data from PDF, the data is not structured at all. So for example, the mutations, we could use that provided at least there could have been one common consensus, and all of this could have been, you know, stored in a database. So which is not the scenario. Every hospital is using their own way of structuring these data or storing this data. And all of these reports that has been generated, they are not transferred to you know, a proper database or anywhere where this data could be searched or queried. So this is one of the limitations. Another is, as I said before, because of the different languages and how we are storing the data, it's sort of this scenario is happening, which is Tower of Babel, you know, like every layer is speaking their own language and there is no way to communicate with each other. Now there are tools like OMOP, for example, common data models are arriving very slowly that are tackling this issue. So they are going to the hospitals and making them, you know, to store their data properly in this in a common data model. So they map the data, and then it tries to convert into some sort of common template. But again, this practice is not very well welcomed. Again, I said, as hospitals have technical limitations, this requires a person with some decent technical understanding to convert these data set or work with OMOP models. So this practice is also quite slow to. And there are other challenges as well, but this will be my the last one that I'm presenting here, which is that there is no communication happening between the hospitals either. So it's not that one hospital, you know, find a patient with certain mutation profile can communicate to other hospital like, hey, look, this patient arrived and it was curious and maybe you would like to know, because of the privacy again. So these hospitals do not know what sort of governance or law policies are there to communicate with different hospitals. And this is the scenario we got to know from our collaborators. This is we are collaborating for the Beacon project. It was a pilot project launched with 7 different hospitals of Catalonia. And in one of the meetings, you know, we got to know that even the hospitals in Catalonia, in Barcelona, even, they are not, there is no way for them to communicate with each other if you know, some sort of diagnosis that they have done in the patient, and they would like to know if others have seen the same patient or profile or not. So this is again one of the challenges. Delia is our collaborator, and I asked her to provide some input, you know, to hear from the real medical practitioner, and she sent me some of the codes. So I put here. For example, she says that we have had a lot of problems regarding the data protection and privacy of data in terms of sharing. Even though it is clear that the privacy of the patient is not at risk, it is difficult to understand the legal responsibilities of different hospitals. Another one, she says that the other thing is the technical limitations of the hospitals. Not everyone has all resources available. And for example, in general, there are no previous databases to start with. So these are and also they are clinicians. They shouldn't be struggling with these problems even, you know, so they have, you know, patients to deal with. But this is the real case scenario, that they are dealing with this sort of problem and they do not know how to tackle them. So what are the possible solutions? And because we are addressing the sensitivity of the data, so one obvious solution that we can think of right now is that instead of what is happening before, is that you're submitting the data into common data, you know, central database, and then you make, so every hospital, for example, they submit the data into central database and they make the query. So one obvious solution is to distribute it. So you make the query, the data stays where it belongs. The query should be distributed, you know, so the query should be like a central query, and you distribute it and to ask if you have this in your data. So at least what we are tackling with here is that, you know, your data is totally in your control. You can choose not to answer the query, for example, or what level you can answer. So this was one of the obvious, as I said, scenario, and we started with that. Our Beacon project was born by this idea. And before presenting the Beacon project, I would like to quote this very famous quote, which is, "Those who explore an unknown world are travelers without a map. The map is the result of the exploration." So Beacon version 1 was launched as, in the dark, like, let's see if it works or not. So it was a very basic, simple way of creating this tool, and was just to see, let's see if it works. And if it works, we are going to create a bit of more map, we are going to go more granular. So this was launched, version 1 was launched in 2018 in the collaboration with GA4GH. GA4GH, as I mentioned before, it's a global alliance for genomics and health community. They are scientists or people participating all over the world, tackling different challenges around genomics data set, and data discovery was one of the challenges. So the basic idea for the Beacon project was that you do not tell us what else is in your data set. Just tell me, do you see this mutation at this position? For example, you can make a query, do you see C at chromosome 13 at this position? And Beacon can return yes or no. So just by returning this Boolean answer, yes or no, you're not exposing any other information. And again, the data is with you. You're not sending any data to any central entity. And let's see, if it works or not. So it worked. It was a successful launch of version 1. The version 1 of Beacon was adopted by many other community. And after looking at the success of this, what happened is that version 2 was launched. So version 2 was to extend it from Boolean answers, yes or no. Let's extend to some more information. For example, do you also have information about biosamples or individuals? What can you tell me about this mutation? What sort of individuals this mutation belongs to? Other genomic variations like annotations, what kind of gene this mutation is on, runs, analysis, etc. So this was then Beacon. This is the recent version 2 that we are working on. And this is the extension of version 1. In a layman terms, I can say it's like before in version 1, if you would, you would see that you can ask Beacon, like, do you see mutation X at position Y on chromosome Z? Beacon would return yes, but that's it. There wouldn't have been any more response. With Beacon V2, what it can do is then, if you ask and at what else, it can also tell you that, okay, this mutation was observed in this disease, A, B, C, and C. You can also ask, like, do you have other phenotypic information or studies or annotation of this variant? And Beacon can tell you yes, or you can apply for more information, apply to this data access or apply to this entity, etc. So this is how Beacon has evolved. And basically what I presented before is that the model of the Beacon is based on typical genetic testing. So if you are going for a genetic testing, the basic things are you go for a biopsy, for example, and then you prepare the sample, you do the DNA sequencing, then you analyze the sequencing results by following certain tools and pipelines. You differentiate between the healthy or the reference genome and the patient, what sort of mutations are highlighting, and then the medical intervention follows up. So the model right now for the human Beacon model, because Beacon model could be also used for COVID data, virus data, or plant data, plant genomics, or anything, but this is for the human Beacon model. So again, I said as an individual, we have, fields like gender, age, ethnicity that you can fill in. For the biosample, there are fields for, where the biosample was taken or what sort of procedure was done, what sort of sequencing machine was used, all the information related to runs and analysis, what sort of, analysis was done, which pipeline did you use, which version, if somebody wants to reproduce your result, what sort of, what they have to do. Again, about cohorts, you can find information about, recruitment of cohort for certain disease, for example, Alzheimer's or schizophrenia. Data set type, more information on the data set if you have similar data set like what I'm looking for, and of course, genomics variants. So these are Beacon models. And again, so you take all of this information that you have, like individual biosample, run, etc. What you do then is to beaconize your data. So beaconizing is basically that whatever data you have, it could be biobank sample data, registries, phenotype, genotype, summary data of the patients. Beaconize is the training that we are giving now. It's or you can access the GitHub page. So basically, you take all of those data, You convert it into Beacon-friendly format. You add the VCFs. If you have the VCFs of those files, you submit it into the MongoDB or a database of your choice, and you put the API on the database to ask for queries, so request and response. So this is the basic example. And the idea is, again, this pilot project that I mentioned with the hospitals of Catalonia. So the idea is that each hospital beaconize their data set, whatever data set they want to expose or they have, and then, or the permission layer, they can decide. And then once these all of these modules can be, summed together, like aggregated together for an aggregated query and response. So some user should be able to send a query to all of the common, as a common query, and the query is distributed, and wherever the response is generated, the response should be collected, aggregated, and shown it back to the user. The idea, again, from there on, is to put beacon network all over the world. So wherever the beacons are lit up in the data set, they will be highlighted that, okay, they are here, and the query, like a common query, should be sent to everywhere around as a beacon network. Again, as I said, that you as a data provider, all of the power is in the hands of who holds the data. So they can only show to produce response of Boolean, yes or no, and not more. They can choose to make it for registered users, so they can choose to elaborate their response a bit more, or they can choose, like for the controlled setting, to show more of the information. So the beacon comes with different, the sort of flavors that people can, or the data provider can choose what is the level of access they want to show it to the user. This is one of the example. For example, this person queries for certain variant in certain disease. This would be the query, and then in Boolean response, it will only show, yes, I see this mutation C to T in public version. If you want to access, for the other responses, it will tell you have to log in or whatever else you want to provide a criteria for showing more, seeing more responses. This is for full version. In full version, you can see, more about this variants, what type of variant it is, or the annotation, or case level, or patient genders, for example, which sort of gender or what age group this will belong. So this is the full access version. There are many institutes that have already tried to adopt this beacon. So you can also light a beacon on your data set. So this is the beacon verifier tool that tells you if all the steps that you have done for installation, for the beaconizing your data has gone right or wrong. So all the greens you see is that everything has gone well. Red is that there is something missing. Go back and take a look in your data set. White is because not everything is mandatory. So you can also choose to skip. For example, if you do not have individual data, anything about individual data or metadata, you can skip this endpoint. So Beacon version 2 was recently approved in April 2022 as the first specification of genomic data discovery by GA4GH. This is Jordi, our PI, who is presenting in the community about this Beacon version 2. And after presentation and common discussion and consensus, it was approved as a genomic data discovery specification. Where we want to go with Beacon is to make the query as intuitive as what we do on Google search. So it shouldn't be that, it should be complicated. If we are looking for certain mutation or certain patient group, we would like that Beacon, that you type as you type on Google, and, it should show you similar. As I said before, like people do not have any option and they're going to Facebook and creating groups. So instead of that, we would like Beacon to go that for any individual, it should be very intuitive to search this information. And again, in the large perspective, we would like that Beacon becomes this internet of genomics sort of. So where, for example, you go on Google to find things on internet, likewise, people should come to Beacon to find genomics related information or query. With this, I would like to thank the Beacon team. It's a whole team involved. Many people who have contributed directly. For example, I presented Manuel's and Roberto's work here. to people who have, with GitHub commenting, or, just having looking at the, just assisting us or providing their feedback, valuable feedback. So it has been a large consortium that has been part of this. And specifically, thanks to Team EGA, everyone together here, all of us, try to do a little bit better for the genomics data community. And thank you for your attention and your patience. And I would like to take questions if you have any. Thank you.